In this video, I'll be explaining divisibility tests for integers. First, let's talk about what divisibility means. We say an integer is divisible by another integer if, when they are divided, the result is also an integer. Essentially, what that means is when you divide, there is no remainder or there is no decimal portion. For example, we say that 24 is divisible by 8 because when we do divide 24 by 8, we get an integer 3. And again, there's no remainder or no decimal. Now, you might want to know why you should know these, because you could always, of course, just check to see if something is divisible by using your calculator. But if you are performing long division, or you don't have a calculator or are not permitted to use a calculator, knowing these divisibility facts can help you go a little more quickly. Also, when you're doing the prime factorization of a number, it might help you to kind of build where you start, those first two factors that you're going to break your number up into. And of course, when you're finding the greatest common factor of a set of integers, this will definitely be useful. And you could also use it when you're simplifying fractions, because remember, you want to divide by the same number in the numerator and denominator. And of course, when you're factoring polynomials, you're going to need to know what the factors of one of the coefficients of that polynomial is, and these tests can help you to find them. Now again, it's just to test if you can divide by a number. It does not give you the quotient or the answer when you do in fact divide. So we're going to start with divisibility by 2. So the test is to look at the last digit of the number. Any number that ends in a 0, a 2, a 4, 6, or 8 is divisible by 2. We also refer to these as even numbers. For example, the number 67,324 is divisible by 2 since the last digit is 4. The next test is for divisibility by 3. And here, if the sum of the digits is a number that is divisible by 3, then the original number is also divisible by 3. So for example, we have the number 114,870, and that is divisible by 3 since when you add the digits 1 plus 1 plus 4 plus 8 plus 7 plus 0, you get 21. And we already know that 21 is divisible by 3. Now, this test can be done over and over again, so even if you didn't know that 21 was divisible by 3, if you add the 2 and 1, the digits of this number, you get 3. And we know that 3 is always divisible by itself, just as any number is. Next we have divisibility by 4, and this is looking at just the last two digits of that number. So if the last two digits form a number divisible by 4, then the original number is divisible by 4. For example, 76,516 is divisible by 4, since the last two digits form the number 16, which is divisible by 4. Next, we have divisibility by 5, and again, here you just have to look at the last digit, and if that last digit is a 0 or a 5, then the number is divisible by 5. So in the example, you have 33,125, and since that last digit is a 5, you know that entire number is in fact divisible by 5. Now we have divisibility by 6, and the test here is actually to perform two tests. So if you see that the number is divisible by both 2 and by 3, then it is divisible by 6. So in the example, you have 45,018, and that is divisible by 2, since the last digit is an 8. And that number is also divisible by 3, since when you sum up the digits, you get 18, which we know to be divisible by 3. And therefore, we know that 45,018 is divisible by 6, because it does work for 2 and for 3. Okay, now we have divisibility by 9, and this test is very similar to divisibility by 3. So here you're going to sum up the digits, and if that sum is divisible by 9, then the original number is also divisible by 9. So in the example, 6,489, when you add the digits together, 6 plus 4 plus 8 plus 9, you get 27, and we know 27 is divisible by 9. But again, you can keep adding the digits together just to test to see. So if we weren't sure about 27, we could add 2 plus 7, That gives us 9. We know that 9 is divisible by itself. Okay, here we have divisibility by 10. This is a nice easy test. If the last digit is a 0, then the number is divisible by 10. So in the example, we have 723,880 ends in a 0. Automatically, we know it's divisible by 10. Now this also works for any powers of 10. 10, 100, 1,000, 10,000, 100,000, 1,000,000, so on. You really just want to look to see how many zeros are at the end of that number. So in the example you see here in green, 3,400, since there are 2 zeros at the end, you know it's divisible by 100. And then the number 174,000 ends in 3 zeros, so we know it's divisible by 1,000. Now that's to say that even though something ends in 3 zeros, we know it's divisible by 1,000, that's automatically divisible by 100 and by 10 as well. Okay, our final test in this video is divisibility by 12. And this is similar to the test for 6, where you are going to use tests for 2 different factors beforehand. And here, if the number is divisible by both 3 and 4, then it is divisible by 12. For example, the number 40,332 is divisible by 3, since when we sum the digits we get 12. And this number is also divisible by 4, because remember the last 2 digits form a number, 32, that is known to be divisible by 4. Therefore, we know that this number, 40,332, is in fact divisible by 12. Now, in this video, I just talked about some divisibility tests. These are not all of them. There's a test for 8. There's a way that you can test for 11, but they're not as useful, and I think the test for 8 kind of requires you to kind of use the calculator a little bit, and that's not the point of this video. This is to help you to see and use these tests to make your division or even multiplication a little bit faster without the aid of a calculator. So I hope you enjoyed, and have a good day.